Hello dear students. So I am here with a very important, a very fundamental chapter, a very important chapter for NEET, CET and JEE mains. What is it? It is P block elements. Students, I hope you have watched all my videos on S block elements, all my videos on hydrogen, redox reactions and various other chapters. Okay? Yes? See, if you have watched my videos on S block elements, okay, then wherein in S block elements, under S block elements, I have covered all the fundamentals of the periodic table. Okay, so if you have watched my videos on S block elements, the P block elements will be somewhat easy. Okay, students, we know in P block we have got 6 groups. Is that correct? Okay, from group 13 to group 16. Group 13 to group 16. Okay, sorry, group 18. We have got 6 groups in P block, isn't it? Okay, group 13, which we call it as boron family. Okay, group 13 is called as what? Boron family elements. Boron family. Group 14 is called as carbon family. Carbon family. Group 15 is nitrogen family. Nitrogen family. Group 16 is oxygen family, which is also called as chalcogen family, or else let us understand it by oxygen family itself. Group 17 is halogen family. Halogen family. And group 18 is noble gas family, isn't it? Noble gas family. Is this correct? So we have group 13 to group 18 in P block. But nothing to worry, students. We are going to study this P block elements in 2 parts. In first part, we will talk about only 2 groups, that is group 13 and group 14. Okay, and in the second part, we will study the elements from group 15 to group 18. Group 15 to group 18. Group 13 to group 14, we will study this in 11th standard. Okay, whereas from group 15 to group 18, we will study this in 12th standard. So, therefore, in 11th standard, we have got to study only about 2 groups. Group 13, which is called as boron family, and group 14, which is called as what? Carbon family. Carbon family. I hope you understood my point. So, before that, before we actually divide the P block elements, into 2 parts, in part 1, group 13 and group 14. In part 2, we will talk about the elements from group 15 to group 18. So before we classify the P block into part 1 and part 2, let us understand the basics of P block elements. And remember this, students, under P block elements, we will study the properties of each and every element that is there in P block. We will study the properties of every element that is been there from group 13 to group 18. Okay, we will not leave even a single element. We will study all the physical properties, we will study all the chemical properties of each and every element that is been there in group 13 to group 18. Okay, so before we study all the physical properties and all the chemical properties, and before we classify P block into part 1 and part 2, let us understand the basics of P block elements. Okay, let us understand the basics of P block elements. By the way, students, what are P block elements? That is what I said. If you have studied, if you have watched my videos on S block, all these fundamentals will be easy for you. Because I have discussed all the fundamentals of the periodic table under S block elements. Now, no problem. If you have not watched the videos on S block, come on, at least now tell me what are P block elements and why there are 6 group in P block elements, and tell me whether the P block elements are metals or non-metals or what. Okay, yes, can you please answer all these questions? What are P block elements? Okay, yes, why there are 6 groups in P block elements? And then, okay, what is the nature of P block elements? Are they metals or are they non-metals or are they something else? Okay, and what is the electronic configuration, outer electronic configuration of P block elements? Okay, if you can recall, we have understood that all the S block elements, S block had 2 groups, group 1 and group 2. Group 1 elements are called as alkali metals, group 2 elements are called as alkaline earth metals, correct, which is placed at extreme left of the periodic table. P block is placed at right of the periodic table, isn't it? Okay, yes, can you please tell me what are P block elements? Okay, don't you think carbon is a P block element? Yeah, carbon is a P block element. Oxygen is a P block element. Yes, oxygen is a P block element. Nitrogen is a P block element. Yes, nitrogen is a P block element. Aluminium is a P block element. Yes, aluminium is a P block element. Then what are P block? Why carbon is regarded as a P block element? Why oxygen is regarded as a P block element? Why nitrogen and aluminium are regarded as, or why they have been put under P block elements? What are P block elements? If you can look at its electronic configuration, if you look at the electronic configuration of each and every element, okay, see, we know the atomic number of carbon is 6. What is its electronic configuration? 1s2, 2s2, 2p2. Okay, yes, 2p2, isn't it? Now, carbon has 6 electrons. First electron goes to the 1s orbital. Second electron also goes to the 1s orbital. Third electron goes to 2s orbital. Fourth electron goes to 2s orbital. Fifth electron goes to 2p orbital. Sixth electron, the last electron, okay, enters the last p orbital, isn't it? The sixth electron enters the last p orbital. That is why carbon is a P block element. Okay, what is happening to the last electron? Where is the last electron going? The last electron enters the last p orbital. We call last electron as valence electron. We call the last orbital as valence orbital. Correct? Okay, so the valence electron enters the valence p orbital. That is why carbon is called as a P block element. Simple. Okay, how about oxygen? What is its atomic number? Oxygen atomic number is 8. What is its electronic configuration? The electronic configuration is 1s2, 2s2, okay, 2p4. Look at here. Where is the last electron going? The 8th electron. The last electron means the 8th electron. The 8th electron enters the valence p orbital. That is the last p orbital. Correct? Okay. Look at carbon. The last electron enters the last p orbital. Look at oxygen. The last electron enters the last p orbital. Correct? Okay. Same in case of nitrogen. Nitrogen atomic number 7. What is its electronic configuration? 1s2. 2s2, okay, 2p3. Is this correct? Look at the 7th electron. The 7th electron enters the last p orbital. Okay, what is the atomic number of aluminium? 13. Okay, yes, its electronic configuration is 1s2, 2s2, 2p6, 3s2, okay, 3p3. Look at here. The last electron enters the last p orbital. The last electron enters the last p orbital. So my conclusion is, okay, for those elements or the elements in which the valence electron enters the valence p orbital are called as P block elements. Do you agree with my point? If the valence electron, that means if the last electron enters the last p orbital, the valence electron enters the valence p orbital, they are called as P block elements. Am I correct? Okay, yes, the valence electron enters the valence p orbital. The valence electron enters the valence p orbital. Valence electron enters the valence p orbital, and the valence electron enters the valence p orbital. So those elements in which the valence electron enters the valence p orbital are called as p block elements. They are called as what? P block elements. Okay, simple. Okay, by the way, what are s block elements? The elements in which the valence electron enters the valence s orbital, they are called as s block elements. Okay, whereas those elements in which the valence electron enters the valence p orbital are called as what? P block elements. P block elements. Am I correct? Okay, and we also know that p subshell has 3 orbitals. P subshell has 3 orbitals, isn't it? Which are those 3 orbitals? They are px, okay, py, and pz. Correct? P subshell has 3 orbitals: px, py, pz, and each orbital can accommodate how many electrons? 2 electrons. Each orbital can accommodate how many electrons? 2 electrons. So altogether, how many electrons can a p subshell have? P subshell, okay, I'll write it here. P subshell can have 8 electrons, isn't it? P subshell can have P subshell can have how many electrons? 6 electrons. 2, 4, 6. Am I correct? Okay. There can be 2 electrons in px orbital. Okay. There can be 2 electrons in py orbital. There can be 2 electrons in pz orbital. Okay. So each orbital of p subshell will have 2 electrons. That means altogether p subshell can have how many electrons? 6 electrons. That is why p block has 6 groups. That is why p block has 6 groups. That is from where to where? From group 13 to group 18, isn't it? Okay, yes, group 13, group 14, group 15, group 16, group 17, and group 18. Am I correct? Okay, so I hope you got the answer. Why p block has 6 groups? Okay, p block has 6 groups from group 13 to 18. Why it has 6 groups? Because p subshell can have how many electrons? 6 electrons. Since p subshell can have 6 electrons, there are 6 groups in p block. Which are those 6 groups in p block? Group 13, group 14, group 15, group 16, group 17, and group 18. Understood? Okay, look here. Okay, yes, see, in group 13, p subshell is filled with 1 electron. The filling up of p subshell starts from group 13. Okay, yes, filling up of p subshell starts from which group? Group 13. So in group 13, okay, p subshell is filled with 1 electron. In group 14, p subshell is filled with 2 electrons. In group 15, p subshell will be filled with 3 electrons. In group 16, p subshell will be filled with what? 4 electrons. In group 17, p subshell will be filled with 5 electrons. And in group 18, p subshell will be filled with how many electrons? 6 electrons. Therefore, I can say filling up of p orbitals starts from group 13 and p subshell is completely filled in group 18. Okay, yes, hope you remember this point. Okay, so now filling up of p subshell starts from group 13 and p subshell is completely filled in group 18. Hope you understood my point. Okay, any doubts with this? So since p subshell can accommodate 6 electrons, there are 6 groups. Now let us write all the elements from group 13 to group 18. Shall we write all the elements from group 13 to group 18? Everybody? Yes. From group 13 to group 18. Please remember this. Okay? Yeah. Group 13, group 14, okay, group 15, group 16, group 17, and group 18. Okay? Yes. So in group 13, we have, okay, boron, aluminium, okay, gallium, indium, and thallium. Okay, which are the elements of group 13? Boron, aluminium, gallium, indium and thallium. In group 14 we have carbon, silicon, okay, germanium, okay, tin and lead. Tin and lead. Got it? In group 15 we have nitrogen, phosphorus, arsenic, okay, antimony and bismuth. Okay, yes. In group 16 we have oxygen, sulfur, selenium, tellurium and polonium. Okay. In group 17 we have what? Fluorine, chlorine, bromine, iodine and astatine. Okay. In group 18 we have what? Okay, neon, argon, krypton, xenon and radon. Okay, yes. Okay, neon, argon, krypton, xenon and radon. So these are the elements that we come across from group 13 to group 18. Well, okay, group 13 elements are called as what? Boron family elements. Group 14 elements are called as, okay, carbon family elements. Okay, group 15 elements are called as nitrogen family elements. Well, they are also called as nicogens. Okay, what are they called as? They are also called as nicogens. Why are they called as nicogens? We will study that in part 2 of P block. Okay, okay. Group 16 elements are called as oxygen family elements, or else they are also called as chalcogens. They are called as what? Chalcogens. Okay. Then group 17 we have halogen family. Okay, fluorine, chlorine, bromine, iodine and astatine. Group 18 we have inert gases or noble gases or rare earth elements. By the way, okay, please remember 15 group elements are called as what? Nicogens. Okay, 16 group elements are called as chalcogens. Okay, 17th group, okay, elements are called as what? Halogens. And okay, 18th group elements are called as rare earth elements or inert gases. Okay, they are also called as what? Inert gases. Okay, and students, okay, what are these P block elements? Are they metals or are they non-metals or are they something else? Remember, all S block elements are metals. All D block elements are also hard metals. All F block elements are also hard metals. S block elements are metals. D block elements are metals. F block elements are also metals. It is only in P block. We find metals. Okay, we find metals. Okay, we find non-metals. Okay, we find what? Non-metals and metalloids. It is only in P block we find metals, non-metals and metalloids. Nowhere in the entire periodic table except P block we find non-metals and metalloids. Non-metals and metalloids are found only in P block elements. Then out of these elements, students, which are metals, which are non-metals and which are metalloids? By the way, what are metalloids? Can anybody tell me what are metalloids? Okay, see, metalloids are those okay, whose properties lie in between what? Metals and non-metals. Metalloids are those elements whose properties lie in between metals and non-metals. So which are those metals, which are those non-metals and which of them are metalloids? Look at here, please observe here. Okay, yes, I am going to draw a zigzag curve. Observe this. Okay, yes, Yes, observe here. Yes, look at here, the one which is written in zigzag manner. See these elements, that is boron, silicon, germanium, arsenic, antimony, tellurium and astatine. Okay, yes, which are those? Boron, silicon, germanium, arsenic, antimony, tellurium and astatine. Okay, tellurium and astatine. Okay, any doubts? These elements are what? Metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium and astatine. These elements are what? Metalloids. Okay, and the metals, the elements that lie above these metalloids are non-metals. The elements which lie below the metalloids are metals. Are you getting my point? So all the elements that lie above the metalloids are, okay, non-metals. The elements that lie below the metalloids are metals. So that means aluminium, gallium, indium, thallium, okay, tin, lead, bismuth, polonium, they are all metals. Whereas carbon, nitrogen, phosphorus, oxygen, sulfur, selenium, fluorine, chlorine, bromine, iodine are what? Non-metals. Okay, hope you understood. Okay, so the elements in this zigzag manner, they are metalloids. The elements above metalloids are all non-metals. The elements below metalloids are metals. Okay, understood. So it is only in P block. Okay, we observe metals, non-metals as well as metalloids. Okay, got it? Once again, please recall the elements in the zigzag manner are metalloids. Okay, the elements above metalloids are non-metals. The elements below metalloids are what? Metals. Okay, no doubts with this? Okay, so students, okay, with this basic understanding, let us now divide this entire P block from group 13 to group 18 into two parts. In part 1, we will talk only about group 13 and group 14. Whereas in part 2, we will talk about from group 15 to group 18. So shall we start now? So in my next upcoming videos, okay, yes, we will be talking only about the elements of group 13 and group 14. Which are the elements of group 13? Okay, yes, we have boron, aluminium, gadolinium, indium and thallium. Okay, which are the elements of group 14? It is carbon, silicon, germanium, tin and lead. So now we will talk only about the elements of group 13 and the elements of group 14. Here also we will study group 13 separately and group 14 separately. Understood? So now I'll be starting with what? Boron family elements. Let us talk about all the properties of boron family and then we will go with the properties of what? Carbon family elements. Understood? Okay, yes. Okay students, now let us start with boron family elements. Okay, yes. Okay, we're going to start with boron, okay, family elements. Boron family elements. Okay, yes. Which are the elements of boron family? They are boron, aluminium, gadolinium, indium and thallium. Can you remember Bal Gangadhar Tilak? Bal Gangadhar in Tilak. Okay, please remember that way. Bal Gangadhar in Tilak. Okay, so we have these elements of group, okay, 13. So here we have got to discuss both their physical properties as well as chemical properties. Okay, now we have already understood that, okay, boron is a metalloid. but in our textbook it is given as non-metal. Yeah, of course. Okay, yes, of course it's a non-metal, but the chemical properties of boron resembles that of a metalloid. That is why I said it's a metalloid. Whereas all the elements from aluminium to thallium, these elements from boron, aluminium to thallium, they are all what? They are all metals. Okay, aluminium is a metal, gallium is a metal, indium is a metal, thallium is a metal, whereas boron is a non-metal, or it can be regarded as a metalloid. Now, when we are talking about the physical properties of these elements, when we speak about the physical properties, see, we have got to discuss about their electronic configuration. Okay, we will discuss about what electronic configuration first. Okay, then we will speak about the variation of atomic radii. We will talk about the variation in ionic radii. We will talk about the variation in oxidation state, density, melting point and boiling point. Okay, now my point of interest is electronic configuration of boron family elements. What is the electronic configuration? What is the general outer electronic configuration of p block elements? Okay, well, by the way, what is the atomic number of boron? Anybody please? Okay, what is the atomic number of boron? Boron atomic number is 5. 5 plus 8, 13. 13 plus 18, come on, 13 plus 18 is, 13 plus 8 is 21. 21 plus 18 is 39. Am I correct? Okay, 39 plus 32 is 39 plus 39 plus 32. How much? Okay, yes, is it not 71? 71, correct? Okay, yeah, boron is 5. Okay, aluminium is 5 plus 8. Okay, 13. 13 plus 8, 21, isn't it? 13 plus 8 is 21. They are all second period elements. Since they are second period elements, we have to start by adding 8. Okay, so 5 plus 8, 13. 13 plus 8 is 21. 21 plus 18 is 21. Okay, 21 plus 18 is 39. Okay, yes. Okay, and then 39 plus, so here we have added 5 plus 8, 8 plus, 8, then 18, and then again 18, I'm sorry. Okay, yes, 39 plus 18 is 57, I'm sorry, it is, the atomic number of thallium is 57, understood? Okay, from here to here it is 8, from here to here 8, from here to here 18, from here to here also it is 18. Okay, simple. Okay, now let us write the electronic configuration of these elements. Let us write the electronic configuration. What is the electronic configuration of boron? It is 1s2. See, this electronic configuration of boron family elements is at most important, because when we want to explain their atomic radius, when we want to explain their ionization enthalpy, when we want to explain their oxidation state, we can explain only on the basis of their electronic configuration. So please better learn the electronic configuration properly. Okay, so the electronic configuration of boron is 1s2, 2s2, 2p1. Very good. Okay, so 2s2, 2p1, correct? Aluminium, it is 1s2, 2s2, 2p6, 3s2, 3p1, isn't it? 3p1, correct? Okay, any doubts? Yeah. Gadolinium, 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2, 4s2, okay, yeah, 4s2, and then what? Okay, it's already 20. We are missing something here. So 5 plus 8 is 13. Okay, from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Okay, so from here to here it is 2, from here to here it is 8, here to here 8, 18, 18, and 32. So since we are already starting from second pair elements, that means we have to start with this, correct? Okay, 5 plus 8 is 13, no doubt. 13 plus 8 is 21. Okay, 1s2, 2s2, okay, 2p6, 3s2, 3p6, 4s2. Okay, no, somewhere we are going wrong. Okay, is this correct? 3s2, 3p1. Okay, 1s2, 2s2, 2p6, 3s2, 3p6. So already 20. Okay, how about this? 13 plus 18. Yes, 13 plus 18 is 11. 11, 31. If I take this as 31, okay, 31. Okay, can I say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, 3d10 and 4p1. So I'm sorry. So here we have to add 18 and 18. So 31 plus 18 is, okay, yes, 49. 49. 49 plus 32 is, okay, 81. Okay, please correct the electronic atomic number. 5, 13, 31, 49 and 81. 81. Okay, so the outer electronic configuration of okay, gallium is going to be, okay, boron, aluminium, gadolinium, indium and thallium, correct? Okay, yes. So 4s2, 4p1. Okay, and then how about indium? It is 1s2, okay, 2s2, 2p6, come on, 3s2, 3p6, 4s2, okay, then 3d10, 4p6, correct? Okay, 5s2, okay, 5s2, how much? 10, 20, 30, okay, 38, 38, okay, yeah, 4d10, 5p1, look at here, 5p1, okay, then thallium, 1s2, 2s2, 2p6, like that it goes, okay, and then we will get what? 6s2, 6p1, 6s2, 6p1. Just observe the outer electronic configuration of these elements. What is the outer electronic configuration of boron? It is 2s1. The outer electronic configuration of aluminium is 3s2, 3p1. Okay, gallium, it is 4s2, 4p1. Okay, indium, it is 5s2, okay, yes, 5p1. Okay, then thallium, 6s2, 6p1. Okay, observe here, 2s2, 2p1, 3s2, 3p1, 4s2, 4p1, 5s2, 5p1, 6s2, 6p1. Okay, therefore, what is the general outer electronic configuration of these boron family elements? Of course, it will be what? ns2, np1. The general outer electronic configuration of, okay, yeah, okay, what is that? Boron family elements is going to be ns2, np1. 2s2, 2p1, 3s2, 3p1, 4s2, 4p1, 5s2, 5p1, 6s2, 6p1, 6s2, 6p1. Are we clear? So the general outer electronic configuration is ns2, np1. Any doubts? So where did we go wrong? Here, when we are computing with the atomic number. Okay, so atomic number from here to here, okay, I'm sorry, from here to here it is 8. From here to here it is 18, from here to here it is 18, and from here to here it is 32. 32. Are we clear? Okay. So observe the electronic configuration: 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1, 6s2 6p1. Therefore, the general outer electronic configuration is ns2 np1. No doubts? Okay, clear? So that is all about the electronic configuration, the general outer electronic configuration of boron family elements. Do remember ns2 np1. No doubts with this. Okay, now, okay, next one. Okay, very important. Very important. Okay, the atomic radius of boron family elements. Atomic radius of boron family elements. Atomic radius. Okay, how does the atomic radii vary from boron to thallium? Okay, how does the atomic radii vary from boron to thallium? Okay, yes. So students, let us talk about the atomic radius in the next video. Okay, thank you.